In lesson 6.6, we learned how to solve and graph absolute value inequalities. And we talked about two different kinds of inequalities. We have ones that are greater than and ones that are less than. Now we talked about in class how the greater than problems represent or problems and the less than represent and problems. But let's break that down and do these two problems here. So this first problem on the left, the absolute value of x minus 5 is greater than or equal to 7. What I want to do is I want to figure out, first of all, if this is an and or an or problem. So what I do is I picture this. I don't usually draw this out, but I'm going to draw it out so that you can see it here. I'm picturing a number line from -7 to +7 and zeros in the middle. Now this inequality shows we think of the absolute value as the distance from 0. So I think of this as the distance from 0 is greater than or equal to 7. So on my number line, I'm going to try to figure out where are the numbers that are greater than or equal to 7 spaces or numbers away from 0. I have to determine, are they the numbers between negative and positive 7? Are those numbers greater than 7 away from 0? Nope, they are not. So then it has to be all the numbers outside of the negative and positive 7. So all the numbers to the right of 7 are greater than 7 spaces from 0, and all of the numbers to the left of -7 are greater than 7 spaces from 0. Remember, when I say spaces, I'm not referring to this number line. I'm referring to a standard number line. I colored in my circles, making them closed circles because of this equal to sign that was part of the original problem. All right, so now I'm going to break this absolute value problem down into two separate ones, just like we did with equations. But I'm going to use this graph over here on the right to help me do that. I'm going to say that x minus 5, if we look at this part of our graph, it's going to be less than or equal to -7. And this is an or problem because they go in opposite directions away from one another. And then I'm going to use this arrow on the right to write the other one. X minus 5, that's from the original problem, can be greater than or equal to +7. So now I have my two inequalities that I'm going to solve. And I'm going to solve them separately by adding 5 to each side. So I've got x is less than or equal to -2. And over here I've got x is greater than or equal to 12. This is an or problem. I've got to write the word or in the middle. So one of my answers, or I guess it's my answer to this problem, is x is less than or equal to -2, or x is greater than or equal to 12. Now we have to graph that. Remember, that number line we made at the beginning was not our graph. That was just to help us figure out which way our arrows were going. So when we make number lines, we're going to make a really simple one, and we're just going to include the two numbers that are in our answer, -2 and 12. And I would say x is less than or equal to -2. That's a closed circle, points left. X is greater than or equal to +12. That's a closed circle, points right. So these are our two answers to this problem. Remember, this is not part of our answer. Now let's take a look at a less than problem. This is going to be what we call an and problem. So to do this problem, I'm going to draw that little number line at the beginning again to help me visualize this, -1 and +1. Now remember, this right here, the absolute value, we say it represents the distance from 0. That helps us figure out if it's an and or problem. So the distance from 0 is less than 1. So if we look at our number line, we got to ask ourselves, which numbers on the number line are less than 1 from 0? So 0 is right here in the middle. So that would be these numbers in between negative and +1. Those are all the numbers that are less than 1 away from 0. So we connect them in the middle, and this is what we've been calling an and problem. Okay? So when we have an and problem, we take the part that's inside the absolute value bars and that becomes the middle of our inequality. And if we're going to use this number line up here to help us, we would say that it's got to be less, because this is going this way, so it's less than positive 1. But if we look over here, this one's going to the right, it's got to be greater than negative 1. Now remember, I wrote the less than sign here when I said greater than because I'm reading it right to left. I think of this as x plus 2 is greater than negative 1. All right, now we just have to solve this inequality. We're going to subtract 2 from all 3 parts. I don't have to flip my sign around because I did not divide or multiply by a negative. And I end up with x is greater than negative 3 and it's less than negative 1. So if I were to graph this problem, I put my negative 3 and my negative 1. We're making really simple number lines. I've got open circles because it does not have the equal to, and an and problem, they meet in the middle. So my solutions to this problem are everything between negative 3 and negative 1. Remember, this number line we made at the very beginning, that is not part of our answer. That was just to help us set up the problem.